Hello, herzlich willkommen. Welcome to the Drupa Cube. So whether you're at Drupa to showcase your latest breakthrough, or to forge new partnerships, or simply to marvel at the wonders of modern printing, please know that you're part of something truly special. After 8 long years, Drupa is back. So get ready to be inspired, as I like to say. What can you expect here at the Cube? The Cube is, some of you have already been here, so you already know. Forgive me if I'm repeating myself, but for those who haven't yet been here, it's the primary conference venue here at Drupa, and we aim to bring you actionable insights into business leadership, into sustainability, into global trends, and the topic of our next session, future print and packaging technologies. So let's dive right into the next presentation. We'll be looking at the environmental impact of inks with the help of something that's very important for transparency, LCA. Everyone know what those 3 words stand for? 3 letters? Life cycle assessment. Great. This session has been organized by the VDL, which is the German Ink and Coating Association. Our speaker has not only a PhD in chemistry, we're in safe hands, she has recently been promoted from Head of Innovation and Technology to Head of Technology at Epple Druckfarben, and that means she's involved in procurement, supply chain, logistics, and she'll tell us more. Epple is a sheet-fed ink provider for commercial UV and packaging based in Germany. So please give a warm welcome to our speaker, Dr. Vroni Walter. Stage is yours.
Hello, so I'm very happy that I made it. So I come from Augsburg, which is in southern Bavaria. And maybe you have seen in the news, there was a lot of rain and a lot of flood. So it was quite a journey yesterday to come here. And this actually fits right to the topic that I have, because extreme weather phenomena is something that we know as a consequence of climate change, so there's no denying. I think usually you say a flood like that is there once in 100 years. So we're now in year 24 of the century, and I think we have already 5. So yeah, that should keep us thinking. So my talk today is about the general aspects, what is a sustainable ink or what is sustainable in general, because I think that sustainability is the challenge or our challenge of this century. And I believe it does not only matter in our private lives, but even more maybe impact-wise in the business life as well. But it's hard to quantify, because what is sustainability? What is a sustainable ink? How can we measure it in order to improve? And sustainability is a complex concept. There are many dimensions. It's not only the environmental part, it is also social and economic aspects that have to be considered as well. And those are even harder to quantify if you think about it. Sustainability is more to only take that what can be regrown. It also means to take only that kind of actions that do not disrupt the important systemic planetary system to And these planetary systems are called planetary boundaries. And these planetary boundaries are a concept and have 9 different dimensions. It is the introduction of novel entities. It's both new chemicals, new materials, but also new organisms. It's a stratospheric ozone depletion, atmospheric aerosol loading, the acidification of our oceans, biochemical flows, both nitrogen and phosphorus, that's where the N and P stands for, freshwater use, land system change, the integrity of our whole biosphere, and climate change. And over the years, this concept of the planetary boundaries has been developed continuously. And now, today, we have limits and thresholds for each of this category. And when you can see and compare the illustration from 2009, 15, and 23, you see that more and more of these thresholds are being exceeded. And this is especially critical because these dimensions, these categories, they're often interconnected. And impacts in one dimension often is triggering a domino effect in others. But there's also good news. The current state of a planetary boundary is not fixed. And the ozone layer is a great example of a past environmental crisis where immediate and decisive action led to the restoration of this planetary boundary. In this talk, I want to focus on climate change and the carbon footprint as a measure of climate change, because it's the most familiar at the moment. But the logic behind assessing the carbon footprint also applies to all of the other categories. And there's no rule that dictates which one of these categories is more important. So sometimes it's really hard to assess an overall sustainability. What was mentioned already, life cycle assessment, is the method of choice. Because now that we know what we want to measure it, the question is, how can we measure it in a reproducible and systemic way? And life cycle assessment is the systemic approach over all the stages of a product's life cycle. And thereby, you combine the contribution of the different steps or materials, whatever you use together, you have to evaluate it, and then you can have a comprehensive understanding over the whole product life cycle. But it is important that you have high-quality data, that you have a transparent communication over the whole supply chain, and that you work together with the informations and especially the quality of the data. So it's really difficult to make a general, comparable assessment that you can compare. System boundaries, for example, are very important. This means the data that you deliberately include and data that you not include. And sometimes it makes very much sense to not include data. For example, if it's based on a lot of different assumptions and you don't know exactly which step to contribute it to, but you have to tell. And there are some very good instructions how to do that, and this is especially important to say how you did it. But what is especially important is that when you have numbers communicated, you also have to check what is included into the data. And if you have two products or two different manufacturers, you cannot generally say, well, one is smaller than two, because you don't know what was contributed to that number. And there are two approaches in life cycle assessment, depending on the number of different process steps you take into account. And this also comes down to how good is your data quality and what do you know about the whole supply chain. The product's life starts with the extraction and the manufacturing of the raw materials. Then the product itself is made, produced, transported to the end customer, it is used, and at the end, it meets its end of life. This can either mean recycling, reuse, or disposal in many cases. And if you want to calculate over the whole supply chain or the whole product life cycle, you would do a cradle to grave analysis. But for that, you need to know all the different contributions. For printing inks, our product, we produce it, we have raw materials, we know our process. maybe we have an idea about the transportation, but then we don't know what happens further with our ink and which substrate and so forth. So we would have to make a lot of assumptions later. So the best thing to do is then to take the steps where you have good data, good control, and calculate a cradle to gate, so when the product leaves the manufacturing plant. Because that enables producers or later manufacturers of packaging to start there with their calculation on a good databases. So usually it is a cradle to gate approach that is used by manufacturing. Yeah, and from all the different impact categories, the carbon footprint is the one that is most discussed and most frequently asked about by customers. Have you ever asked for a carbon footprint for one of your materials? Who has done that already? How was the answer? Okay, good. So not so many answers yet, because it's difficult. It's really difficult to say, even though we have the most idea about that impact category. If you talk about ocean acidification of raw materials or products, it gets even more complicated to get good quality data. And in the carbon footprint, it's not only carbon dioxide that is used, but it's important to know it's all climate active gases. And there are different protocols how you can do that. They vary a bit, but the idea generally is the same. And for the carbon footprint, you take direct and indirect emissions and summarize them over the chosen product life cycle stages, and then you get a number, and depending on your method, your system boundaries, yeah, you get a different number actually. You can do that on two levels. You can, on one side, you can calculate a more general company carbon footprint. This is usually a bit easier because you don't have to attribute it to product streams. Or you can calculate a more selective product carbon footprint. That means what is the amount of carbon dioxide equivalents for 1 kilogram of your product. But that can be challenging because you have to attribute general values like heating and so forth to the one product stream. So this is also something to take into account if you get data and have to see how reliable it is, or if you add something, if you use further. So you can always add some like 5% uncertainty when you calculate further, depending how good the data is. Usually when you have it from raw materials or products, then it's a cradle to gate product carbon footprint, what you are looking for. Looking deeper into the carbon footprint of printing ink, or generally this applies for most of the chemical products, there are different scopes that contribute. And scope 1 are direct carbon emission. It means where directly on-site fuel combustion takes place, or in some of the steps in between carbon dioxide or equivalent gases are emitted. Scope 2 is a more indirect emission, and it comes from purchased heat generation or electricity, for example. And for scope 1, you have really good data. So you know exactly what you do, what you sold. Maybe you have a good emission factor from your supplier. And scope 2, you can calculate it pretty good as well, because you know how much you bought. You can have good information from your supplier there as well. The real challenge is scope 3. Scope 3 is everything else. So it's all the raw materials, the transportation. It is everything in between, upstream, so raw material-wise, and downstream, so what your customer, your next in line does with it. And as I mentioned before, it's pretty important to know exactly what is done. So usually it's the upstream emission that are used for a cradle-to-gate approach. You can see in the pie chart, scope 1 and scope 2, that's pretty small. This is where you have great data. And scope 3 is the part which contributes and dominates the most, but this is the part where the data quality is difficult because you rely on the information you have from your suppliers. And they might be in the same spot that you are. So they don't have the information from their suppliers in a data quality that would give them the opportunity to calculate a good and detailed product carbon footprint. And for printing inks, the raw materials are the main source of these scope 3 emissions. So it's really not so much the production plant, not so much the electricity you use. We use in our companies, it's the raw materials, the production of the raw materials themselves that count the most. And we have, in a typical printing ink, we have binders, usually from resins or solvents or oils. They are pretty okay from carbon footprint-wise because a lot of them are grown already, are plant-based, which is great for the carbon footprint, but might be difficult in other impact categories, for example, land use, fresh water, also social interaction, depending on the country where they're grown. And then we have additives. This can be a lot of different things, but the most contribution to the carbon footprint are the synthetic organic pigments usually. And it's very hard to replace them because the printing technology has a high technical requirement, and to find innovative alternatives that also meet those requirements is a pretty hard challenge. But the demand of the customers or from the change that we have in our society as well, it also leads to interesting ideas of suppliers themselves. For example, make precursors not with general chemical pathways, but to use bioreactor, enzymatic reactions, things like that. And there's fascinating what is possible already in a laboratory, but it has to be available in large quantities so that the next steps, so the manufacturers can use that in their products. And that's the reason as well, because this close collaboration between the suppliers and manufacturers and customers is key, because you have to understand what works for the next step, for example, technical-wise, but also what is possible on the other side to qualify these new materials. And when they're there, there's still one hurdle that remains. New materials initially may be more expensive. So the speed of the adoption of new materials will also depend on the customer willingness to invest in sustainability. But from a personal standpoint, I'm very confident that now that we have the demand with the innovation and the collaboration, that there's a lot of things that we can do to improve the products and the sustainability in the whole printing industry. So let's dive into the printing process. This is the value chain of a printing ink that is used then later for a packaging fulfilled good. As an example, there are many different applications where printing inks can be used. The printing ink itself is made of additives. Most of the printing ink from a volume-wise is a resin or varnish. Then you have pigments, depending on the system, also solvent. The printing ink is one raw material, again, itself, for the packaging, and the other is the substrate. And in comparison to the substrate or additional materials, depending on the design, you have a very, very small contribution of the printing ink to the overall printed product. In estimation, it is actually the substrate that contributes most to the carbon footprint of a printed product. Then, when you have both raw materials together, you print it on a printing press, you use energy, maybe you need additional materials, such as a dampening solution or overprint varnish. And this is also a great example for system boundaries. The printing press itself was manufactured as well. So there was an economic, there was a social, there was an environmental impact by producing this machine. But usually a printing press or similar infrastructure is omitted when you calculate a product carbon footprint of a printed product, because you would need to know the total amount of printed sheets for the machine to get a value that you then add to the printed product. And you cannot look into the future. I can't. So you would have to estimate, and then you again get purer data, less good data. So usually you write in your life cycle assessment, this was not included into the, in the number, in the calculation. Then the packaged product is then transported to supermarket, it is sold, it is used, and then the packaging usually goes into the waste. And depending which kind of inks are on the packaging, which kind of substrate, for example, there can be different waste streams. For paper packaging, it's quite nicely that you can reuse the fibers when you de-ink the ink from the substrate to recycling paper, for example. This can be more difficult when you have plastic substrates, but also there's technology that makes that possible. That looks kind of straightforward, but in the practical part, it is not, because there are many options when you can have variations. So, for example, how was your packaging designed? So, which kind of materials were included? Was there print on paper, print of plastic? Was there, the product sold entirely, for example, or was it disposed of before it was sold? How was it transported? So there are a lot of things you don't know. So the most meaningful result or number you can get for the whole supply chain or product life cycle is when you're at the end, you know all the data, all the steps, all the specifics in between, and then you can calculate the carbon footprint for that. And besides the term footprint, there's also the term handprint. Has anybody ever heard that before? Yeah. It's pretty cool because it's a way to indicate a positive implication of a product at some point in the stream, in the value stream, that it has on later steps. Because it might have a carbon footprint that stays the same, but if you change the product design so that you need less cleaning agent, or you need less energy to cure it, or you need less heat, something like that. So it has a positive effect on later steps of the product life cycle, so it's a handprint to indicate that. That's quite interesting. For example, the inking would be a good property for later sustainability impacts in the supply chain. Okay, so how do we do it? This guideline should give an impulse as well, because in theory this sounds very easy, you just have to do it, but there's so many things you have to take care of. How can you make sustainability one of your priorities as well? And the first part is the most important part, but often the least followed. You really have to make it a management priority. Only then you have the resources and the awareness to drive real change. You can do that when you include specific measurable goals into your company's strategic agenda. And to find the right targets, you need to know where you stand right now. You need to make a determination of the status quo. And in the beginning, this is the most work. You have to make the right basis of data. You have to create that mostly. Then you have to find the best method for your industry, for your sector, and for your product. But if you start and calculate your first carbon footprint or other impact category, then it gets easier because it's very easy to spot the contributions or the processes or materials then who contribute most to the emissions, for example. Then you should take challenging but realistic targets because you want to fulfill it in a defined time frame. That is important as well. Implement the measures and plan it rigorously. And that can include to make process optimization, change your energy source, reduce your energy in general, also redesign your business model, redesign your product, or look for alternative raw materials. And it is worth to look beyond the familiar and also look into different sustainable concepts such as chemical as a service or benign by design principles for product design. Then the last part of a cycle of improvement is, of course, to re-evaluate to see if the measures you have taken led to the results you wanted, to learn maybe from mistakes, assumptions that you made, set new goals, and then, start again, because there is no end to being sustainable. It's always continuing, set new targets, and become better. So what should you look for to help? And by now, I hope I convinced you that good data is important, a solid method is important, and you find both best when you look for science-based and generally accepted targets. Some for carbon footprints and other impact categories are given, and there's often, they have the same idea, they have the same principle, but they might differ in details. And then depending on your product, depending on your industry, some may fit better than others. And then it is helpful to look to your association, for example. You don't have to invent the wheel on your own as a company. You can look, what is your industry's best practice? Are there any examples or models you can look for, or for industry standards or harmonized guidelines? And for us printing ink manufacturers, there is the German Paint and Printing Ink Association that is important on the national level, and on the European level, it's the European Printing Ink Association. And both associations are very active, so we have a lot of helpful documents, and they work closely together as well. For example, there are guidelines for us printing ink manufacturers, how to calculate a product carbon footprint, also with a lot of different overviews and so forth, what a general overview over different printing system and so forth is. So this is really very helpful. And maybe in your industry you have that as well. So at the end of my talk, I would like to summarize and highlight the most important parts. It is crucial that you understand all the different contributions in the whole value chain, because if you optimize one part, but it has a negative effect on later steps, you don't win much as a whole. And in order to change something, to take specific actions, you need to know the hotspots of your own process. For printing ink and printed products, the printing ink is usually a very, very small contribution to the overall product carbon footprint of a printed product. And from that, raw materials have the most contribution. So this is also because that this is a hotspot for printing ink manufacturers. And we as printing ink manufacturers want to reduce our environmental impact, and we want to take a holistic approach together with suppliers and our customers, because only over the whole supply chain the most improvements can be made. So ultimately, it comes down and it depends on how well we will work together as an industry and how much we really want it as a society. And that's, I believe that if we want, then we can. Thank you.
Fantastic. Thank you so much for this overview. Please stay. We have some time for questions from the audience. Would you like to ask anything? We've got the microphones coming around. There we go. Put your hand up if you'd like to ask something, then loud and clear in the microphone so we can all learn from your question. I have a question about, from the beginning of the presentation, how did the planetary boundaries go from 7 to 9? What was the difference there?
It has been 7 categories, so it has been, it was divided in some of the parts when the science of it showed that there are different systems, because each of the planetary boundary is a system itself, but it contributes to other categories, because sometimes it's then difficult to say this is this and this is this. So it was refined over the years,
Okay, because I couldn't quite read from where I was sitting, the one with 9 on it, and I didn't know what had changed.
We can have a look.
Yeah, there. What was the difference there? The two boundaries added, right?
It was the assessed, how many were already assessed where you have a threshold. That's the difference from the illustrations.
Mm-hmm.
Yeah. So we did not know, before in 2009 and 2015, we did not know what the threshold was. So we didn't know it was there, but
Okay.
Yeah.
Good.
So we had no numbers to know how bad it is.
Right.
Yeah.
Any questions from the audience? Over there? There was a nod? No, not from you. So now you've got a new role where you're also in charge of supply chain. How do you find the information flow from suppliers? Is it transparent? Do you get the information that you need?
It's different for each supplier. So some are really on the forefront. Some have very good data. Some, they struggle to get that from their suppliers as well. So it's very mixed. We have numbers, for example, for carbon footprint. We have numbers now from all of our raw materials, but you cannot just take what you get. You have to evaluate the quality. And with some, we're not happy enough to base calculation on that. Because we have one, for example, where there was plus minus 50%. That can be a lot. Yeah.
Okay, and how do you work with suppliers to improve on that?
Yeah, so we usually go directly to the sustainability expert of the suppliers when they already have some, and then we talk together. So what have you included? When do you think you will have better data and so forth? And then we can make an estimation as well to have better numbers. But I think the most responsible way is to take, when you have numbers like that, take the plus 50%, take the worst case.
Right.
Yeah, and then when the data gets better, then you can have a better value yourself. And this is, for example, something that you would give as data transparently to the customers as well. So this is our number, and we think we have an uncertainty of plus minus because we're not sure about the data quality, or this is the data quality that we got. I think it's important to say that and communicate that, because then suppliers or customers later in the supply chain can have a better communication further on. You can only say what you know. If you don't know, maybe it's wrong, yeah.
Okay, what about the role of certification? You've had some ISO numbers there. Is there, there certifications that you look for, that you can rely on?
Look for, yes, but they're usually very general. So, for example, it's given, calculate all the most important parts of the emissions. But if you don't take the whole picture, you don't know what is important. If you want to say, I want to be 90% accurate, you need to know the 100% first to know what is the 90% of it. So they're helpful in the systemic approach. Sometimes they're not so helpful in what you really should do in detail, because they have to be accurate for a lot of different companies, a lot of different products. So they're more general. But usually association and industry standards help more in the practical part.
Okay. Any questions from the audience? Okay, probably time to have lunch. Thank you so much for your attention. Please do give us a quick feedback using the QR code. Thank you for visiting and you're coming all this way for your very interesting talk. Thank you, Dr. Vroni Walter.
Thank you.